Greetings to Lab 2 Part 4. So in this part, we're going to take a look at exercise 3.13, which is a nice application of the normal distribution out there to the real world. In particular for those of us who have been fortunate enough to endure airports baggage claim, okay, and in these days what they consider to be overweight luggage. So let's go take a look. I've already got the problem pasted up into my RStudio Markdown file. If you need a second, you might want to pause this and go ahead and do that. And I've opened up a chunk already to go down here and do my work, okay? And again, as I said in the previous videos, it may take a bit of editing on these to get them all cleaned up, but you're good most parts. It's a heck of a lot easier than typing the whole thing in. So suppose the weights of the checked baggage for airline passengers follow a nearly normal distribution with a mean of 45 pounds and a standard deviation of 3.2 pounds. Most airlines charge a fee for baggage that weigh in excess of 50 pounds. Determine what percent of airline passengers incur this fee. So let's go get to the whiteboard and let's go draw this situation and see if we can make this make sense. Okay, so let's give ourselves a blank whiteboard here. And the first thing, as usual, since we're working with the normal distribution, is we're going to go ahead and, this is 3.13, we're going to go ahead and start off with drawing ourselves a bell-shaped normal distribution, or some people affectionately call it a turtle shell, okay? All right, so they gave us the model here. They said that the baggage weights, that's what X represents here, are normally distributed with a mean of 45 pounds and a standard deviation of 3.2 pounds. And so what that means is that the center of this distribution right here, mu, is equal to 45 pounds, and the standard deviation sigma is equal to 3.2 pounds. And I wanted to go the hassle of writing this down for you because I wanted to point something out to you real quick here, is that the units of the mean and the standard deviation are going to be the same. In other words, whatever the units the mean is in, the standard deviation will be in the same units. All right, so they ask us to find out what's the probability, if we're in this distribution, what's the probability of a randomly selected passenger having their baggage weigh more than 50 pounds, because that means they're going to have to pay the additional fee, right? In other words, what's the proportion or probability of X being greater than 50? That's what we're looking for. Now contrast this to the last problem. In the last set of problems, in 3.5, we were looking for the position. We were given the area, asked to find the position. This time we're given the position, asked to find the area or the proportion, okay? All right, so let's see if we can draw a sort of an accurate drawing here. We know that 3.2 pounds is one standard deviation, so that should be about 3.2 pounds right there. In other words, that should be roughly at about 48.2 pounds right there. So 50 pounds is going to be, somewhere in this neck of the woods right here. And what we want to know is what proportion are greater than that. So we're looking above that. So the shaded region right here, this shaded region is what we're looking for. That's what we want to know. In other words, we want to know what is that shaded region right here. Okay, so to calculate that, hopefully at this point it's getting a little bit easier. We see that the calculation here is going to be a p-norm because we're doing a proportion. So how do I calculate a p, or how do I calculate a proportion? In RStudio, I use p-norm, all right? So p-norm, and then what do I need to give it here? Well, I need to give it the position, which in this case is 50, and the mean, which is 45, and the standard deviation, which is 3.2. Now, the thing is that you have to remember is that when I do this, what I just wrote down right there, the area that it's going to give me back is not the area I want. It's going to give me back this green area right here, because remember that RStudio, just as like our printed tables, just like pretty much all of the software packages and stuff out there in the world, they're left-tailed tables. There's exceptions. There's some people that do right-tailed tables, but for the most part, they're going to be left-tailed, all right? So what that means is that this right here, that's the green area, isn't it, right? Well, that's not what I want. What I want is I want to have that purple or magenta area up there. So in order to be able to get that, I'm going to have to do the 1 minus trick. Okay? hopefully that makes sense. Whenever it's a greater than, we're going to do 1 minus. Whenever it's a less than, we're going to leave it alone, right? So greater than, that infers that it's going to be a 1 minus p norm, right? Comp book worthy stuff there, right? Oops, my bad. I said greater than and I wrote a less than. I'm getting ahead of myself. Sorry about that, you guys. Erase that. Don't write that down. My bad, okay? So if it's a greater than, there we go. Put the right symbol in, Mike. If it's a less than, then that infers to us that we're just going to do p norm. Okay, cool. Let's go get over to RStudio now and let's actually do the calculation. This one's a pretty straightforward once we got all that done. So we're going to come down here and we're just going to type in 1 minus p norm of 50 by 45 by 3.2. There we go. Another comma there. All right, let's go ahead and run that chunk so we can just see what we got there. So go ahead and run current chunk, and it comes back to basically 6%. So about 6% of passengers will incur this fee. Okay, so just a quick aside before we finish this off. You'll notice in the textbook when they do these, since they are using the table, they have to convert everything into a z-score first. So if you want to convert the z-score just to see what it's going to be, that's it's a cool thing. It obviously is not necessary in order for us to calculate the probability or the proportion. But so just as a bonus, you don't have to do this. If you wanted to see what the z-score would be for this, well, how would you do that? Well, I'd come in and say, okay, I got to take x, which is 50, minus mu, which is 45, there we go, and I'm going to divide that by 3.2. Okay, so let's go ahead and run that chunk again. And we get that it's about 1.56 standard deviations above the mean. So, not quite what we would infer to be an unusual event, but getting there, okay? All right, well, hopefully that helps, and we're going to come back to the next one. Before you get started, you might want to go ahead and open up assignment 2 because we're gonna go recycle some code out of assignment 2 for assignment 3.